Hello, this video is about the RO skids and their modes of operation. Over here we see our permeate tank level. Over here you'll notice an HOA selector. This stands for hand, off, and auto. Hand will start a skid regardless of the permeate tank level, unless the tank is in a high alarm, in which case it will put the skid in off. Off will keep a skid from starting. If a skid is running and it's switched off, it will initiate a post-flush and a normal shutdown procedure. It will also put all the valves and devices in operator mode so the operator can take control of these devices. Auto will start and stop a skid automatically based on their priority. We have three different priorities: primary, secondary, and standby. Primary will start the skid when the permeate tank is at 85% or lower and turn it off when it reaches 91. Secondary will start the skid when the permeate tank is at 80% and lower and shut it off at 85. Standby keeps a skid idle even if auto rotate is on. We can only run 2 RO banks at a time. We do not have enough raw water to supply all three. We also need to run all the RO skids once every 12 hours. We have an idle timer on each skid, and these are alarmed. We also have an auto rotate. In order to enable auto rotate, all three skids must be in auto. When auto rotate is enabled, your priorities automatically switch. Primary becomes standby, standby becomes secondary, and secondary becomes primary. Let's take a look at our interlock. To change from standby, another unit must be selected as standby. This is done to prevent all three skids from being turned on at the same time. Changing priorities is not permitted when auto rotate is enabled. This makes sense because when auto rotate is enabled, auto rotate is changing the priorities. Now let's take a closer look at filter bank 1. We've already talked about our HOA and our priorities. Now let's learn about CIP. CIP stands for clean in place. This is a fairly manual process. The skid is isolated and chemicals are circulated through the skid. The skid cannot be in auto during CIP. It must be in off to prevent contamination to the rest of the system with the cleaning chemicals. Right here we didn't have anything to simulate other than an operator doing it. This is for simulation and will not be on the final graphic. A control stop push button will be located on each skid next to the control panel. This is not an emergency stop, but it will shut the skid down quickly. Over here we have our inlet pressure. We have our post filter pressure. We have our pressure differential, our main inlet valve. We have a flow transmitter in gallons per minute, inlet pressure, inlet temperature, our booster pump, which is on a variable frequency drive. We vary the speed of the booster pump to control the output of the RO skid. We have a percent of full load on our pump. This is our inlet pressure for the RO skid, and this is the booster pump's discharge pressure. RO skids are constantly creating a reject water or concentrate water. First, this water goes through a second RO bank, and some of that water goes to the permeate tank, and the rest of the water goes out the reject line or concentrate line and gets sent to the waste tank. There's a throttling valve on this line that helps control the flow going to the waste tank. This valve has a feedback position and a deviation alarm that will cause a critical alarm 1. If we look over here, we have inlet pH, conductivity, and ORP. ORP stands for oxygen reduction potential. These only alarm and no action is taken. However, if our outlet conductivity gets too high, it will cause a permeate divert. Upon high conductivity, the permeate divert valve, which we see right here, will open. 10 seconds after a confirmed open, of this divert valve, the permeate discharge valve, will shut. I will now demonstrate a permeate divert. This takes a few seconds. Uh-oh, we have high conductivity. You'll watch this valve, you'll see it's opening. 10 seconds after a confirmed open of this divert valve, this permeate valve will close. And now we are diverting to the waste tank. We will acknowledge our alarm. Now we'll show you what happens during a normal shutdown. This is the same thing that happens if we have a critical alarm too. Right here in the middle of the screen, it will talk us through what it's doing. It's going through a normal stop. We're ramping down the pump. Once the pump stops, we begin a post-flush. This post-flush happens with just inlet water pressure. The booster pump remains off. You'll notice the permeate valve's closed. We're flushing through the divert and the reject line. Post-flush, all the valves in the system close. Now we're going to go through a normal startup. We're opening valves and checking inlet pressure. Upon confirmation of pressure, we will start our pre-flush. Once again, this is done with just inlet water pressure. The booster pump will remain off. When the pump starts, it will start at 30% speed for 30 seconds before it starts controlling flow. Now it's in service and controlling flow. We're going to demonstrate a critical alarm 1 and the way the system shuts down. This is the same as if you do a control stop push button. In this case, all the valves will close, everything will stop, except for our throttling valve, which will open to 100%. Okay, let's say we don't know what caused our critical alarm 1. Let's go to our first outs. Right here at the top of the page, we see control stop push button. It could have also been a high alarm on the discharge from the RO booster pump. It could have also been a deviation alarm on the throttling valve, or it could have been a high level in the waste tank. These 4 things will create a critical 1 alarm. Now let's go back, acknowledge our page. Down here, we see normalized data and flow totals. This information is used to set a maintenance period for the CIP. Thank you very much.